All right. We're going to solve exponential and logarithmic equations. Where's Bella today? She's usually here by now. Gina being late is normal. Jameson being late is normal. But Bella, I don't know. Have I seen a message about it? Let's see. Nope. Who knows? Maybe she's sick. Maybe she's running late. It will be unusual, but not impossible. We've also discovered something interesting that I think we probably knew already. That you people that are currently here are not the talkative group. Man, this is going to be a rough class. Okay, let's jump in with an example. There are several tools we can use for solving logarithmic equations and inequalities. All of which you kind of already have, sort of. Let's do this one. The log base 9, that's definitely not a 9. Base 9 of x equals 3 halves. First tool in our tool belt is convert forms. So right now this is in logarithmic. Let's turn it to exponential form, shall we? What would it look like in exponential form? 9 to the 3 halves equals x. What is 9 to the half equal? So this would equal 3 cubed. What does 3 cubed equal? 27. Not so bad. Let's do another one like that. We'll do this one like a guided practice, so we'll let you do it, and then I'll write all the work on the top. Log base 16 of x equal 5 halves. Ready, go. X would equal 1,024. Easy peasy. Let's do another style, shall we? Let's throw an inequality in there. Jameson, is there a reason you're sitting there writing nothing? Is there a reason you're sitting there writing nothing? because you've been sitting there a while. Let's join class now that you're here. Thank you for showing up. Sorry you were late. I know it was probably not your fault. It's probably your parent. Totally fine.
Actually, it was on me.
Okay, well.
I thought today was the day of the court hearing, and I was thinking, was it going to be online? Because there was nothing.
Was there anything sent out about me being on jury duty? No. No, there wasn't. True enough. True enough. True enough. But now that you're here, welcome. Glad you're here. Join the class. Physically and mentally, we got this. Okay. Let's throw an inequality in there. Let's do the log base 4 of x is greater than or equal to 3. So, what would we do? Do the same thing as we would do normally. Sounds great. X is greater than or equal to 4 cubed. So, x is greater than or equal to what? True enough. X is greater than or equal to 64. I didn't get put on a jury. It didn't happen. I mean, this is clearly true at this point because we're here in class. But no. I was texted on Thursday afternoon and said, no, you do not have to be on the jury. All right, here we go. Let's do another one. Okay. What will we do now? What's up? $16, true. Okay, now, I want you to do something for me. Are you ready? In your calculator, I want you to push log. Find the log button. Now, if you push, we'll talk about this later, but the log button doesn't have a base written. If it doesn't have a base written, it's actually base 10, called the common log. We'll talk about that in a couple lessons. All right, so that's what you're doing. You're doing log base 10. But I want you to do log base 10 of negative 12. Enter. You take your phone out and turn it sideways on the calculator, it's got a log button. Yeah. I think you have to punch it in backwards, like push negative, whatever I said, 12, and then log and enter, I think, on your calculator. But it broke. What did it tell you? You have a question? What is your question? What are you talking about there? Dude, are you listening to the words that I just said? What did I just say about that? Because what? What is the base when you push the log button? What did I just say? You're not stupid, you just weren't listening, which is different. But now if you don't listen, because as I'm explaining it again, now if you don't listen, that would be stupid. It was just negligent before. But now that you're listening, and now that I'm being clear, the log on there is called the common log. We haven't talked about it yet. If there is not a base listed, it is base 10. So the log on there is base 10. So push log of negative 12, enter. And what happens? Did you find a log on your calculator? Was I right? Was it there? Yeah. Look at that.
It says non-real answer.
Non-real answer, or some other type of, it might say domain error or something like that. Y'all get an error? Why? Yeah, because it's negative. So, but why would that be an error in this case? I'm going to explain it two ways. You ready? First way, I think, is honestly a little bit easier to understand in a way. If I told you to graph y equals log base 2 of x, what is my picture going to look like? X does not equal 2. What does the picture look like? Tell you what's the graph? It looks like, yeah, like that. It's going to be a deal. It has an asymptote. Where is the asymptote? No. At what 0? At the x-axis or the y-axis? At the y-axis. And it looks like this, more or less. Right? That's what this looks like. What is it never going to be? Negative or 0. Never going to be there. Never ever going to get there. Does this make sense? Good. Okay. So we need to add to our answer. Because we said in this particular inequality that x is less than 16. Which is true. Fine. Very useful. But there is a point where it breaks. Because we can go less than 16, less than 16, less than 16, and then we hit a wall. So what do we need to add to our answer? So we have to have x is greater than 0 and less than 16. Why didn't we have to do that on the other one? Because it was greater than. X is greater than or equal to 64. Okay. How we doing? Pretty good? Oh yeah, that's why. When do we start getting to the ugly ones? Probably not until that lesson. This lesson's easy. That's crazy. That's good. What time is it? Okay. Because y'all are in Algebra 2, I might increase the torture and do it a little different than what I did in Algebra. No. Geometry. Yeah. I like it. I like it a lot. It's good. Homework. Number 1. Page is oh no, there is one more type of problem. Good. Yeah, it's easy though, so I'll show you that example. Pages 482 through 483, numbers 8 through 32 evens. Great. All right. We got one more problem type in this lesson, so let's look at it. What if we have something that looks like this? Log base 3 of x squared minus 15 equals the log base 3 of 2x. Let us explain how to do this. You probably have already guessed, but maybe not. Because of exponentials, you may have already guessed. You may not have. But let's explain this with a even simpler example. If I have the log base 5 of x equals the log base 5 of 2. What does x equal here? 2. Same, right? If the bases match, we can just set the arguments equal, right? So when I said this was easy, I wasn't lying, because this, the bases match, so this has to match. So we can say x squared minus 15 equals 2x, and then we can solve for x. So, what should we do to solve for x?
Factor it.
We should factor it. In order to factor it, we need to do something else first.
Oh, we need to write it in the right way. So
Yeah.
minus 2x.
Everything you said is correct. I'm going to add that the way you got there was by subtracting 2x, right? I've got to get it in standard form, or else we can factor it, but it won't be useful because we need it equal to 0. Because in order to factor and set each factor into a 0, it's got to be equal to 0 first, right? Right. Okay, so factor it. What's it going to factor into?
Minus 5, minus 3, or plus 3.
Okay. What now?
Solve.
What do you mean?
X equals 5, -3.
Yes, it would. Because you said each factor equal to 0. X minus 5 equals 0, x plus 3 equals 0, so x is going to equal 5 and -3. Make sure our cobwebs are clean. X minus 5 equals 0, add 5, add 5. That's why the sign's backwards, right? Now, is our answer both of those, one of those, or none of those?
You have to check them.
We can even just check it with our eyes and pitch one of them in the trash.
Oh, because it's negative?
Yeah. And it matters specifically because of this one. This would be okay on this one because the -3 squared is going to be, actually it wouldn't even be fine on that one because we're still going to get a negative. Because we're going to get a, what am I saying? We're going to end up getting a negative because minus 15. So it actually isn't even okay on this one. Right? All right, so it's not this one. So x just equals 5. What if it's an inequality? Let's do one of those. Log base 5 of 2x plus 1 is less than or equal to the log base 5 of x plus 4. So, what should we do?
2x plus 1 less than or equal to 4.
True enough. 2x plus 1 is less than or equal to x plus 4. Now what?
Subtract x plus 4.
I think subtract x and then subtract 1 probably, right? Subtract the x, subtract 1, and we end up with x is less than or equal to 3. All right, what now? So in this case, x doesn't have to be greater than 0, but it is going to have to be greater than something. How do I figure out what the something is? No, not just plugging it in.
You have to make sure it won't be negative.
It won't equal a negative, right? So we can set these greater than 0. So 2x plus 1 is greater than 0. Now you can kind of see where this is going to go. You really are only going to have to do one of them because one of them is going to kind of include the other. So what's going to happen over here? Subtract 1. 2x is greater than negative 1. X is greater than negative 1/2. What about over here? Subtract 4. X is greater than negative 4. So one of these covers the other one. Which one covers the other one? No, negative 4 doesn't cover it. It's negative 1/2. Good process of elimination skills. If it's greater than negative 1/2, then it's also greater than negative 4, right? So this one takes care of this one. So x has got to be greater than negative 1/2. Now you can write this in long form, precursor to set builder notation, or you can do it with interval notation. That's also fine. Interval notation, there would be the answer, right? If you wanted to do it, not set builder notation, but almost, the negative 1/2 is, or x is greater than negative 1/2 and less than or equal to 3, right? And just in case you're curious for next year, we wrote in set builder notation, it would be like this. X such that negative 1/2 is greater than x is greater than or equal to 3. X is a member of, this is an x, the real numbers. Isn't that precious? Okay. All right. Now you are capable of doing all of the homework. Some of y'all are like, well, that's what you think. There are lesson videos for this. If you want them, you can go search them on YouTube yourself. Embry Learning Labs Algebra 2 playlist. But if you don't need them, then you have what you need. Okay, let's start at least 7.5. Properties of logarithms. Properties of logarithms. So we've learned, actually you learned starting in Algebra 1, properties of exponents. Right? It's like where if we have like bases multiplied, you add the exponents. If you have like bases divided, you subtract the exponents. All of that stuff. So all of that stuff, since logarithms are basically exponents, actually the inverse of them, but because they are that, all of those properties basically still apply to logarithms. So let's write them all out. So, if we have log of a product, this is the product rule. So log base x, base whatever, any base this will work for. Of a times b, I know we don't have to write the dot, but for full clarity, that can be written as the log base x of a plus the log base x of b. Which is like the product property in exponents, right? Like bases divided, you add the exponents. Right? Product rule also applies. The log base x of a divided by b, what do you think that's going to equal? Minus log base x of a minus the log base x of b. Power property also works. If we have like bases, or excuse me, if we have a base raised to a power, what do we do with those exponents? Multiply them, which in logarithms works like this. And we have the log base x of a to the b. Then what we can do is we can pull the b out and multiply it times all the thing. So this equals b times the log base x of a. Easy peasy so far? Let's get all the kind of special ones. Except they don't do the special ones in here. Can we do that in common logs? I forget that this book splits. This is, it's not about doing it. I get what they did. I get it. But this chapter, more than any other chapter in this book, I would not have organized this way if I was writing it. And so it always confuses me. But we got this. Y'all don't have to worry about it because you're just going to get it all and be not confused, hopefully. And make sure I'm not lying. I think we get all the specially ones later, which is why I don't understand why you wouldn't do all of the properties in one lesson. Or did we already learn the weird ones? Do we already, like, if I told you this, can you already answer this question? What does that equal? Nope.
1.
It does equal 1. Where is this? Did we not cover this already? And then I'm not seeing it in the future? I know that it talks about these like specialty ones.
I think we did it maybe 2 lessons ago.
Yeah, I think we already did. We already talked about these weird ones. But we'll go ahead and since we already talked about them, we'll get it, and we're kind of doubling up today anyway. If the base matches the argument, it equals 1, because a to the 1 equals a. Easy peasy, right? If I have the log base a of 1, what is that always going to equal? No, 0. Doesn't matter what the base is. It's true. Because anything to the 0 is 1. True enough. True enough, true enough, true enough. Let's toss another one in there that builds on something over there. If I have the log base a of a to the x, what is that going to equal?
-1.
Not -1, but we should certainly write that one in this inclusion of properties. Nope. What does log base a of a equal? 1. And if I have argument to a power, what can I do with the power? Times the whole thing. So x times 1 is what? X. John was asking about another one that we can get in here. If we have the log, he didn't know he was asking about it, but he was, of a, log base a of 1 over a, what is that going to equal? -1. Who'd have thunk that in Algebra 2 we'd be re-saturating our brains in a little bit of number sense? You'd think that would be left behind in elementary. But no, we still get sense for numbers. New numbers with letters in them. Who'd have thunk that letters can have numbers in them and aren't just variables? That's crazy. Actually, the higher you get in math, the more you learn that all letters are just numbers. How's our time? Really good, actually. I think we're going to get this whole lesson. Let's do some examples using some properties. This is the most boring Algebra 2 class I've ever taught. Y'all are like really boring today. I don't approve.
Have you voted yet?
Have I voted yet? No, but I need to go to today, right? Today's the day. Right? Or was it yesterday? Did I miss it? Yeah, that's what I thought. Okay, good. No, I haven't voted yet. I need to do a little bit more research, so I need to do that at lunch and then go vote after school. I don't know if that was less boring, but it was something. This is actually, of any, like, so it drives me crazy. Arguably. See, you made it more exciting. There you go. You got me wound up. Here we go. Easily arguably, midterm elections are more important than primary elections. Easily. This is easily true. And way less people show up to vote at midterm elections. Not that voting for the president isn't important. It is. I'm talking about math, properties and logarithms. I know. I don't, whatever else. Here we go. Back to math. We're going to use the log base 4 of 2 equals 0.5 to approximate the log base 4 of 32. And in order to do this, we have to do properties of logarithms. Okay? So we need to convert this to something that has this in it. So we need to turn 32 into 2. How can we do that? So we could do times. That would be a way to do it for sure, and that would give us like the sum property, right? So we could do 2 times 16, but then we got to deal with the 16, right? There's a faster way on this one, but that way would work eventually. It would just take more steps. Divide by 16. No, 16 divided by 2, which is actually what we would really do. Because if we were going what you're saying, what you're saying, like if we were trying to kind of go the route that you're talking about, we would say log base 4 of 16 divided, just kidding. 16, no, just kidding. Just kidding. You were right to begin with. And then I confused myself. Good job, me. Here we go. So your way would work eventually. But no, not divide or times.
32 is on the 2 to the 5th power.
It is to the 5th power, and that's going to get us there quicker. Log base 4 of to the 5th. Now what can we do with that? 5 and multiply times the whole thing. And they gave us this equals this. So it'll be 5 times the log base 4 of 2. And log base 4 of 2, they told us, is half. So we would take and turn this into 5 times a half. What's 5 times a half? 2.5. Or if you want to be not pedantic, it'd be the opposite of pedantic. What's the opposite of pedantic? 2, you could say 2.5. I don't know. How did I what? Good job. I'm glad you're smart. Okay, continuing on. Let's do guided practice 2 on the bottom of page 488. And I say all of that because I'm not going to write it, I'm just going to read it. Too many words to write on the whiteboard. Take too long. Okay. The loudness, L, of a sound is measured in decibels, given by L equals 10 times the log base 10 of R. Where R is the sound's relative intensity. Suppose one person talks with a relative intensity of 10 to the 6th or, oh, yeah, I got you. I was really confused because 10 to the 6th is definitely not 60, but continuing on. Talks with a relative intensity of 10 to the 6th or 60 decibels. How much louder would 100 people be talking at the same intensity? Okay, so how do we figure that out? $100 in for R, he says. Not quite.
Well, we should put 10 to the 6 for R then.
You think so? No, not quite. Sort of, but not quite. Which one is the 10 to the 6th or the 60? Because one of them is one thing and the other is the other thing. So we are given two numbers. We are given this, we are given 10 to the 6th, and we are given 60. What are these? Because they're different, right? Because this was, as I was reading, and I wasn't really thinking about what I was reading, this does not equal this, right? So these are not the same thing. One of them is an L and one of them is an R. Which one is which? Go back and read in the English words, and which one is which?
10 to the 6 is R and 60 is R.
Where'd you get it from?
It says 60 decibels, and it says before the 10 to 6 relative intensity.
Great. So 60 goes here. And 10 to the 6th is here, is what you're telling me. Sound true? Okay. So, how much louder would 100 people be talking at the same intensity? So which one is staying the same? The L or the R? Which one is the intensity? The R is the intensity. Is R intensity? Yeah, loudness. So we want to see how much louder it would be. So we want to find L when there's 100 people. This is what, how many people, what is this happening? What is happening? Oh, this is just loudness. This is just general loudness. We want to find L, right? So what do we do? What do you think, Brody? You're smirking over there. What you thinking? Okay, that's fine. You're allowed to think shrugged shoulders.
Isn't log base 10 to the 10 a 1?
It is a 1.
So then we put this as 60 equals 10 divided by 6.
10 times 6, true enough. 60 equals 60. Gasp. So, what are we doing to figure out for 100 people?
You put the 10 that's multiplied times the log.
What is this equation for how many people? For one person, true enough. So how do we get this, how do we make this be 100 people?
We would multiply 10
So 6,000 times. Does that number make sense? Yeah, I don't think that number makes sense. So I don't think that's how we do it. Don't think that's what we do. So what do we do instead? I don't know either. I'm lost as you are, which is why Brody was smirking in the first place. I was hoping he was both smirking and had a useful thought, but because I'm struggling too. Let me actually read and not talk while I'm reading and see if we can see something. So I know what the answer is, and the answer kind of makes sense because the key says right here. But let's see if we can figure out how to get there. Loudness L, decibels given by L equals 10 times log base 10 of R, where R is the sound's relative intensity. So it's one person with a relative intensity of 10 to the 6 or 60 decibels. What if it's just not this? But that would still give 60, so that's kind of useless. Suppose one person talks with a relative intensity of 10 to the 6 or 60 decibels. How much louder would 100 people be talking at the same intensity? So where does the 100 go? The same intensity. So which one is this is the intensity, right? R is the intensity? Yes. So 10 to the 6th. This is the same. This wouldn't be right. Because that would be 600 at that point. According to the key, the answer is 20. It's got to be we're using this equals, it's got to be we're using this equals 60 to find the other one. That's what's got to be true. And actually it's a division thing because this comes right after the division bit. So we've got to split it somehow. I don't know. This is a bad example. Let's do a different example that's more useful so we don't continue to waste our time. Let's do this one. And then maybe we'll look it up. Maybe I'll get GPT to explain it to me, and then I can come and figure that out and explain it to you. Maybe.
The only thought I had about that one was like, if you said the answer was 20.
Mm-hmm.
If that's the case, then maybe it's related to like, since it's base 10 and it's like asking for 100 people and that's 10 squared.
Yeah, it's something. It is certainly something like that. This is certainly true. I just couldn't get beyond that enough to explain it well. But yeah, no, it's clearly something along those lines. That's clearly true. You're clearly in the right direction. Let's say, given the fact that log is very similar to the last one, but weirder looking. Given the fact that log base 3 of 7 is approximately equal to 1.7712. We're going to approximate the value of the log base 3 of 49. So, this is very similar to the one we did before. So, what could we do with this? 7 squared is 49. So we've got the log base 3 of 7 squared. Now what could we do?
Multiply 2 times. Take like 2 times the log base 3.
Okay, so what do we get?
2 is equivalent equals 2 times 1.771.
Yeah, I wrote that.
Oh.
Now what? 3.5424. Great. Easy peasy. Okay. Let's solve this using some logarithm properties. Two times the log base 7 of x equals log base 7 of 27 plus the log base 7 of 3. So, what could we do to solve this? X does not equal 30. Yeah, but it's not just log equals log. We got that pesky plus in there.
Could you combine them?
We also got that 2 over there. We could combine them. How could we combine the right-hand side?
Just adding the exponents.
It's not adding. This isn't that property. That property doesn't really even exist.
Oh. You could put it to 2 log base 7 to 27 plus 3.
Nope. What property do we have on the right side? Go back and look at your properties and logarithms. What property do we have?
Would it be log base 7 of 27 times 3?
Times 3. We got the product property. What about on the left side? What can we do with it?
Log base 7 of x squared.
We could turn this into the log base 7 of x squared. What's 27 times 3? 81. Now what can we do? X squared equals 81. Now what?
X equals 9.
Plus or minus 9. There's an error on the board. Where is it? It was intentionally put there. Which I know is not always the case, but I usually admit it. Come on, y'all can see this. It can only be plus. Because if we put negative 9 in there, it's broken. Let's do another one of those. This time we'll do it as guided practice. Log base 6 of x plus the log base 6 of x plus 5 equals 2. Ready, go. don't forget you can ask questions on these guided practice. That's the guided part of the guided practice. All right. Any questions on this problem? Does it make sense? Did you figure it out?
To the 6 squared equals that squared.
Which part?
How'd you get from the log to the extent?
I just turned it into exponential form. 6 squared equals this. Turning it into changing forms was our first tool we learned, right? I think we got time for one more. Let's do one more. No, just kidding. There isn't one more. That's all the things. How about I give you another homework set? Actually, there is one other kind of problem that we should really do, I think. Let me see. Yeah, I'm not wrong. We are going to do one more example that isn't exactly an example in the book, but we're going to do one more. It's using something that we have done 2 examples of, technically, but it's kind of combining a couple things, and we'll throw it in there. And then we'll give you your second homework, and then we'll peace out, Holmes. Okay, so let's use the fact that the log base 4 of 2 equals 0.5, and the fact that the log base 4 of 3 is approximately equal to 0.7925, and the fact that the log base 4 of 5 is approximately equal to 1.1610. To approximate the log base 4 of 20, and we'll also do the log base 4 of 4/3. And if we have time, we will also do the log base 4 of 8. Okay. So what we need to do is we need to turn each one of these into something up here. Now there is also a hidden invisible one always on these kind of problems. There's a hidden tool that isn't written that is worth keeping in mind. And that is the fact that in this case, the log base 4 of 4 would equal 1. So if we can turn these numbers, any one of them, into 2 or 3 or 5 or 4 or some combination of therein, then we can use those tools to approximate this. So what can we do with 20?
5
5 times 4, absolutely. Easily peasy. We've got 5 and we've got a 4. So the log base 4 of 5 times 4. What can we do now with that one?
Get both fours, turn it into a 1.
We're not there yet, but we're going to do that.
Split it into 2 equations.
Not equations, but 2 logarithms. How would it split into 2 logarithms?
Log base 4 of 4 plus log base 4 of 5.
Log base 4 of 5 plus the log base 4 of 4. Now what can we do?
How we can turn the log base 4?
Yeah, we can turn both of those into their decimal equivalents, right? So this one would turn into 1.1610, and this one would turn into 1. So what would the final answer be here? 2.1610. Easy peasy. What about this guy? What can we do with him?
Split it where they're subtracted.
Where they're subtracted. Log base 4 of 4 minus the log base 4 of 3. So we'd have 1 minus 0.7925. So the final answer would be whatever that is subtracted. Your second homework set is on pages 490 to 491, and you're going to do numbers 12 through 48 evens. Goodbye. Have fun. Find somebody that loves you and tell them, Mom, my math teacher was mean to me today. Unless your mom doesn't love you, and then I'm sorry you've had a rough life, because that would not be fun. And just know that I love you. You don't have to give me a hug, though. I mean, you can if you want to, but